Hello students, let us start with the probability theory, which is unit 1 of CTT. Unit 1 also consists of probability theory, random variables and random process. So first in this short video we'll start with the basics of probability theory. So there are some definitions which are there on the screen which we'll go through. An experiment is a set of rules which governs an operation which is being performed. For example, rolling of a die or tossing of a coin is an experiment. Doing it every time, it's called as one trial. That is, performing it once, it's called as the first trial. Second time that you do it, it will be called as the second trial, third trial, and so on and so forth. The outcome is the result, which is result of performing the experiment. You use the probability theory only when the outcome cannot be predicted accurately. We have pure mathematics when we can predict the outcomes accurately. So probability theory is basically used whenever we cannot predict an outcome accurately. An event is a combination of outcomes. For example, the experiment that we take, if it is tossing of a coin, then getting a head or getting of a tail is an event. The probability theory is basically used in random experiments. Random experiment is an experiment which is repeated. Whenever it is repeated, the outcomes can differ. That is, the first time that you do it, the outcome can be different. Second time that you do it, outcome can be quite different. Okay, for example, again, tossing of a fair coin, outcomes, one time that you toss it, it can be a head. The other time that you toss it, it can be a tail. So basically a random experiment should consist of three features. First of all, the experiment should be repeatable under identical conditions. That is, the conditions under which you perform the experiment should not change. Second thing, on any trial of the experiment, the outcome should be unpredictable. Okay, that is, you cannot predict it accurately. And third thing, for a large number of trials, the outcome should exhibit some sort of pattern, that is, some statistical regularity. If you don't have an average pattern of outcomes, then obviously you cannot use probability theory. That becomes a completely random experiment, in which case we cannot use the probability. Most of the times we use the relative frequency approach to define the probability. Let's take an event A, which can denote one of the possible outcomes of a random experiment. Let's take again the same example, that is heads in a coin tossing experiment. Okay, let event A be, meaning that the heads are appearing. Now suppose that in n trials of the experiment, event A occurs any number of times. For example, we perform the experiment 20 times, that is 20 times we toss the coin, okay, and out of that, let's say some 8 number of times the heads appear. So NA is going to be 8 and N is going to be 20. We may then call that ratio, that is NA by N, as the relative frequency of event A. That is, in this particular case, it's going to be 8 upon 20. It's going to be the relative frequency of the event A. This relative frequency is going to be non-negative, obviously, because out of the 20 times, the thing can be, you can have 0 number of heads, all the 20 times you can get tails, or all the 20 times you can get heads, that is 20 by 20 or 0 by 20. Those are going to be the limits. So that NA by N ratio is going to be between 0 to 1. Okay, that is the relative frequency. Now we come for the definition of the probability. So we define the probability of event A as given by the equation 2, where there is P of A is limit as n tends to infinity NA by N. That is, we perform the experiment not just 20 times, but we can take these sets of 20 many number of times. Let's say we perform that experiment 1,000 number of times, and in each set of 20 that we take, okay, we are going to have some particular number NA, and it's almost going to be similar. So that limit n tends to infinity NA by N is going to be called as the probability of an event A occurring. Let us now define some more terms before we go into actual axioms of probability or postulates of probability. Just let's take an example of rolling of a die. There are 6 possible outcomes over here. Okay, whenever you roll a die only once, you can get a 1, or you can get a 2 or 3 or 4 or 5 or 6. So there are total of 6 possible outcomes. These each one of them is called as a sample point. Okay, that is, getting a 1, you can call it as a sample point S1. Getting a 4, you can call it as a sample point S4. Together, all the outcomes together, it's called as the complete sample space, that is denoted by capital S. So capital S is going to be made up of S1, S2, S3, S4, S5 and X6. So we'll just take an example of some events over here. Let event A be getting even number on die. So even numbers means it will, that particular sample of event A will get 2, 4 and 6. Similarly, event B, let it be for odd numbers, so we'll be getting 1, 3 or 5. Let event C be prime numbers, so it will consist of 2, 3 or 5. Now, out of these events, some are called as mutually exclusive events. Mutually exclusive events, for example, if we take event A and B, we see that there is nothing common in between them. So 2, 4, 6 forms A and 1, 3 and 5 forms B, and together they will make up the complete sample space. So over here, probability of A or B, okay, plus sign denotes or, so together probability of event A occurring or probability of B occurring, so together A plus B, it will be given as probability of A plus probability of B. Whenever the events are not mutually exclusive, just take an example of event A and event C, that is even numbers and prime numbers. Here you can see that the number 2, that outcome of getting a 2 is common between both the events A and C. So there is something in common, so that's why they are not called as not mutually exclusive. So event A consists of 2, 4, 6, C consists of 2, 3, 5, 2 being common. So in this particular case, probability of A or C, that is A union C, will be probability of A plus probability of C, but we can see that the probability of getting a 2 is coming twice, so it's supposed to be subtracted. So that's why minus probability of A dot C. A dot C is nothing but A and C, that is intersection. So that is probability of getting a 2 over here, that is to be subtracted, because probability of A also consists and probability of B is also there in that. So with that example, we have covered what is a sample point, what is a sample space. Okay, then the entire sample space S is called as a sure event or a certain event. For example, when we roll a die, either we are going to get a 1 or 2 or 3 or 4 or 5 or 6. So any event that you make a subspace of that, it's going to be sure. For example, getting a 1, it's going to be complete sample space. That is, if we define an event of saying probability of getting a 1 or 2 or 3 or 4 or 5 or 6, all the probabilities will add up and you will get a 1. So whenever the probability is 1, you can say that it is a sure event or a certain event. For example, and the null set, okay, it's called as a null or impossible event. For example, if you roll a die and you expect a 7 to come up, then obviously it's a null or an impossible event. Out of that, a single sample point is called as an elementary event. Whenever an event has only one, that is, for example, if you take the elementary event of a 4 showing on a die, that is only S4, it's called as the elementary event. So with these basics, we'll just go into the axioms of Axiom 1 states that the probability of a sure event is unity, that is, probability of the complete sample space capital S is equal to 1. Similarly, axiom 2 states that the probability of an event is a non-negative real number that should be positive, that is less than or equal to unity. That is, any probability that you take, it's bound between 0 to 1. Okay, 0 means it has never occurred, it's not going to occur, or probability is equal to 1 means that it is sure to occur. So sure event or a null event, and usually we will get some particular number which is between 0 to 1. Axiom 3 states that the probability of the union of two mutually exclusive events is the sum of the probabilities of the individual events. That is, if A plus B is the union of two mutually exclusive events in the class, then P of A plus B is equal to P of A plus P of B, which we have just shown as an example in the previous case. Okay, so in summary, in this class we have defined just the basics of probability theory, all the definitions. In the next class in the next video we'll do elementary properties of probability and go further.